Let's look at an application involving right triangles. So we are told that we have two birds that are sitting in a tree. One tree is at the very top of the tree, and the other bird is directly below it. Okay. We have a bird watcher who is standing 50 feet away from the base of the tree, and they can view the birds with angles of elevation of 60 degrees and 30 degrees respectively. Okay, so that means 60 degrees to the bird at the top, 30 degrees to the bird below. Okay. We're also told that the eyes of the bird watcher are 6 feet above the ground. We want to find the height of the tree and the vertical distance between the two birds. And we want to compute exact values here. Okay, so to solve a problem like this, I would always try to start by drawing a graph or an illustration for this. Okay. The nice thing with problems like this is we're always going to be drawing right triangles. So we have a tree, and I'm not going to get real fancy here. Just draw a vertical line for a tree. And then I have a bird up here at the top and another bird, so I'll put a dot at the top, and then I'll have another point down on that line a little further down. We are told that from the base of this tree, we go a distance of 50 feet, and we get to the bird watcher. Okay, and the eyes of the bird watcher are actually 6 feet above the ground. So this is 6 feet here. If we could also maybe put a little horizontal line in here, I'll just draw a dotted line parallel to the ground, so it's 6 feet above the ground. So from the eyes of our bird watcher, we have two lines of sight. One line of sight goes from the bird watcher's eyes to the bottom bird, and the other line of sight goes from the bird watcher's eyes to the top bird. Okay, and we're told that we know the angle of elevations are 60 degrees and 30 degrees. So remember, angle of elevations are the amount of rotation upwards from horizontal. Okay, so we're not talking about the ground here either, because that their eyes are 6 feet above the ground, but draw a line parallel. That's why I drew that line parallel to the ground. So this dotted line here is the horizontal, and so I know for the bottom bird I have a 30-degree angle of elevation, and then for the top bird I know this whole angle here is 60 degrees. Okay, so I know these two angles here. All right, and my goal is two things. I want to figure out the height of the tree, so I want to figure out this entire vertical length. We'll just call that h. And I want to figure out the distance between the 2 points, the vertical distance between the two birds. So we have a vertical height from the top of the tree down to the ground, and I want to find the distance between our 2 points. Okay, so to do this, let's maybe break this picture apart into two separate triangles. Okay, so ignoring the actual ground. So let's start with the 60-degree angle of elevation. So the bird at the top. So at the bird at the top, we know we have a right triangle. It's 60 degrees, and let's change what I'm defining as h here. Let's say h is the height from the person's eyes up to the top of the tree. So we already know the bottom is 6 feet here. So let's just find h. Because if I do that, then that means that h is actually the opposite side, from the 60 degrees of that right triangle. And I know the vertical side again is the tree, and the person is 50 feet away. So I know now for an acute angle of 60 degrees, I know the opposite side is h, and the adjacent side is 50. Okay, so I have I'm working with an acute angle in a right triangle and to the sides. So that's a trig problem. Okay. And then the other triangle, this is for the 30-degree angle. Right, so this is 30 degrees here. I still know the length of the bottom side is 50 feet, but I'm trying to find, I don't know what the length of this opposite side is yet. Okay, so we might need to get to that. We'll see. All right, because eventually we want to figure out what this distance above the top of that triangle is. But that's what we're trying to find. Okay, so let's start by finding the height of the tree. So we need to find h, and then because that is 6 feet above ground, we'll add 6 to it. So for this triangle, this is our 60-degree angle. H is the opposite side, and 50 is the adjacent side. So which trig function takes an angle and compares it to the ratio of the opposite and the adjacent sides? That would be tangent, right? So we know our function is the tangent of theta is equal to the opposite over the adjacent. Okay, so if we plug our values in here, we know the tangent of 60 degrees has to equal h over 50 feet. All right, and we just saw a minute ago what the value of the tangent of 60 degrees is, right? If we use that 30, 60, 90 triangle, we were able to show that tangent of 60 is equal to the square root of 3. So we now have the square root of 3 is equal to h over 50. If we multiply the 50 across, we find that h, so the height of the tree, or part of the tree anyway, is 50 times the square root of 3. So that means the actual height of the tree, remember h is defined, I defined h to go from eye level to the top of the tree. So that means the height of the tree is 50 square root of 3 plus 6. Now, again, that may feel kind of like a weird answer, and that is measured in feet, by the way. You may not like having just a raw number, but you could certainly type it in your calculator and figure out what that is just as as an approximate decimal value. But for now, we're just going to leave it with the exact value. Okay. All right. So the second part is figuring out the distance between the two birds, which on my original illustration, that was this length x. It was just the distance between them. Okay. And I know we just found the total height of the bigger right triangle. So we know that this length here is 50 root 3. 50 times the square root of 3. So if I could find the length of the bottom part, we could then subtract it from that 50 square root of 3 to figure out x. Well, that unknown side is the opposite side of our 30-degree angle. And so if we're looking at opposite and hypotenuse again, we're talking about tangent. So we can basically follow the same process, okay? So we know the tangent of we know the tangent of theta, which in this case is now 30 degrees. It has to equal the opposite, which we don't know. Let's just call that y for now. So we can say this is y here. So let's say the tangent of 30 degrees is equal to the opposite, which is y, divided by the adjacent, which is 50 feet. And again, we just saw in a previous video that the tangent of 30 degrees is equal to 1 over the square root of 3. So we replace that in our equation for the tangent. We have 1 over square root of 3 is equal to y over 50. And so that means y is equal, if we multiply both sides by 50, we get y is equal to 50 divided by the square root of 3. Okay, and we could go ahead and rationalize that. So you multiply top and bottom by square root of 3. That would give me 50 square root of 3 over 3. Okay, so that's not my final answer. That is the y value. That's that is actually the height from eye level of the bird watcher up to the bottom bird. And I now want to find the distance from there to the top. And I know the whole distance was h, and that's 50 times the square root of 3. So x has to be a 50 square root of 3 minus this 50 square root of 3 over 3. Okay, right? That's taking h minus y, right? Because over here, if we go back to our original triangle, right? If we take y plus x, we have to get h. So y plus x must equal h, which means x has to be h minus y. So that's what I'm subtracting over here. To do this actual subtraction, again, if you look at the numbers are very similar. We have a 50 square root of 3 minus another 50 square root of 3, but it's also over a 3. So if we find a common denominator, we're going to have 150 square root of 3 over 3 minus a 50 square root of 3 over 3. And so x, this distance between the birds, has to be, so what's 150 root 3 minus a 50? It will be 100 square root of 3 over 3 feet.